Hey guys, I'm Steve Tan. I'm a data enthusiast currently working in the PMS industry. And you want to find out more about me, please go to my LinkedIn at Steve7AN. So I want to start this off with a little bit of introduction about myself. Actually, I graduated in computer science, and for the early part of my career, I was doing a lot of development work in mainly .NET technologies and also a little bit of post-scripting. And after that, I shifted to a business analyst and project management role with ISID, working for a global Japanese bank. And soon after that, I shifted into the exciting payments world with WorldPay, managing one of the giants in the marketplace, AliExpress. And that's also when I earned my PMP certification. And to go back to my technical roots in my latest job with Adyen, I'm actually doing a good balance between operational support and technical integration for our merchants. And that's also when I started and completed my data analyst nano degree with Udacity. And that actually piqued my interest enough for me to enroll in the Master of Knowledge Engineering with NUS. So I want to share something cool today, which is a Sudoku solver. And for those of you who are not familiar with what Sudoku is, it's basically to solve Sudoku puzzle, you need to put 1 to 9 on every rows and also on every column and also on every 3 by 3 grid. If you can do that without duplicates, that's how you solve Sudoku puzzle. So this Sudoku solver actually has quite a funny and interesting background story. It started with this quote by Ben Laurie, and what he meant by that was the Sudoku is actually not a very good use of your brain power actually, and that actually motivated Peter Norvig to write an essay along with the Sudoku solver that uses mainly two main ideas to solve the Sudoku, which is constraint propagation and also using search. So the concept behind constraint propagation mainly consists of two main ideas. One is that if a square has only one possible value, then we want to make sure that we eliminate the same value from all the square's peers. And then the second main idea is that if a unit has only one possible value to put it in the square, then we'll assign that square with that value. So this is the code. We're not really going to run through it, but I will go through a very simple example of a simple Sudoku puzzle and using the code and see how we can solve it. So with this simple puzzle, you can see that these are the available options for every square. And if we run the passGrid function on it, we can see that by trying to assign 9 to the square h9, if we quickly scroll through it, we can see that actually what happens in the end is that all the value from 1 to 8 will be eliminated, leaving only 9. And then after that, we'll also start to remove the value 9 from all the peers of this square. So on the second main idea is that if a square can only be assigned with one value, like for example, a6 with 1, then we want to make sure that we put that value here. So just using these two main ideas in the constant propagation actually is more than enough to solve this simple Sudoku puzzle, as you can see here. However, if we use a slightly more difficult Sudoku puzzle and we just use the same passGrid function again, we can see actually it's not enough to solve it. We are still left with a lot of squares with too many variables to fill in. So in this case, what do? We can actually try to brute force it by randomly trying out each value one by one until we solve it. But looking at the available options left, if we just time this 4 times 5 times 3 times 4 times 3, we can see that actually the search space generated will be rather large. So it's actually not a very feasible idea. So based on what we understand from Sudoku and the constraint propagation, actually, it's not too bad because every choice that we make will actually reduce the search space by half. For example, the G2 square has only two values, 8 and 9, so we can just randomly pick one and then see if we can solve it. If not, we'll try the other value. So using the additional search function plus the minimum remaining value heuristic, we found out that actually we are able to solve the previously more difficult Sudoku puzzle. So besides solving Sudoku puzzle, what other real-world application is this approach good for? One example would be scheduling with a lot of constraint. For example, the scheduling for the Box Day 2018. With the same idea, actually, you can try to schedule the whole conference within minutes with all the constraints specified, and also you can test out different scenarios. Too many people to thank and not enough time, so I'm just going to put it all out here. Thank you very much for your attention.